is thrown into the conversation, which is like, let's start with the low-hanging fruits and have an approach that's value for money. And usually that takes us back a moment because we think, wait a minute, that's not the same thing. And maybe it's also not a good idea to approach it that way. Low-hanging fruits, in our understanding, would be I just do whatever is in front of me. And that might be in a global crisis that are impacting mankind, maybe not the best approach to just do whatever comes to your mind. It might be a bit better idea to do this in a more coordinated way and take solutions and take pathways that will actually get us to solve this problem, rather than maybe almost wasting time doing things that just somebody has heard of or that may work or that may get us somewhere. So in our understanding, grabbing the low-hanging fruits will be a chaotic, anecdotal, and not very clear approach, and also not very transparent in terms of decision making. And so it may be a better approach to have a more strategic approach to where we want to go and be able to transparently also document that this is what we are doing will actually address the main issue of the climate crisis, which is lowering emissions that we are blasting into the atmosphere. And so that could be value for money if you are result oriented and maybe look for the best solution that is out there. Of course, part of this challenge is that the community themselves come up with a challenge. And INSO is able to document and express how the activity that is suggested are going to lower emissions, or what activity or lowering emissions in other people's activities within the community. So the point of today is to give you a bit more insights of how that's done usually, and how it's also recognized in BC, which is, of course, an important part because we're dealing with a public body here, the regional district. And of course, this is a contribution that you want to make to the community itself. So it is maybe quite relevant to understand how this thing called greenhouse gases that are causing the climate change are treated and governed in BC. Okay, enough of the introductions from why we're doing it. What are we talking about? Now, very often you hear the term carbon being used or CO2. But if you ask yourself, is there a difference between the CO2 that I'm actually breathing out right now while speaking and the CO2 that comes out of the smoke pipe, a smokestack of a factory or the jet engine? The answer is not really. Chemically, it's the same element. It is all CO2. Sure, some of the isotopes indicators you can differentiate between fossil fuel and the one that we see everywhere around us, but still, it's still CO2. In fact, we are made of CO2. Like CO2 is absorbed by plants and also by the carrot that is growing, and we are eating the carrot, and that's making us up as a person. So thinking that CO2 is a problem might be a bit of a difficult conversation to have, because CO2 is all around us. We are actually a carbon-based life form. So it might be a bit better to be more distinct about what we're talking about. And that is greenhouse gases, which are expressed in CO2 equivalent, but it's still expressed as greenhouse gases, because that's what are the human-made, the anthropogenic emissions that we are emitting through our activity and unbalancing the concentration of greenhouse gases in the atmosphere, which is the cause of the problem that we are facing and the crisis that we are facing. So it might be a good idea that we're talking about greenhouse gases rather than carbon or CO2, because that could be misleading. And again, as our emphasis here is to be precise, transparent, and easy to understand, it's quite important in our view and helpful to be clear about what we're talking about. And it's not just one substance, it's all greenhouse gases that are having the same effect as CO2 that are expressed as greenhouse gases. And of course, they are part of a wider initiative of the sustainability goals, but today we want to just focus on that. It doesn't mean that you can create benefits in other areas of the sustainability goals, like that will be encouraged, but the focus of our session today is to look at the greenhouse gases. How do we know that the concentration of greenhouse gases in the atmosphere is increasing and is part of the problem? Now, there is somebody who has started measuring this, his name was Charles Keeling, already back in 1958, and on a volcano on Hawaii, the Mauna Loa, he started to measure the atmospheric CO2, and he figured out that this is actually rapidly increasing over time. He also realized that there is an oscillation during the seasons. So in summer, the CO2 went down a little bit, and then towards the winter, it went up again. And what that is the effect of the landmass-based vegetation in the northern hemisphere that is absorbing CO2 out of the atmosphere when it's growing, and then releasing some of it again when it is decomposing. So that's the oscillation that you see there in red in this graph here. And of course, he then realized that it is steadily increasing. And if you compare this with the increase of fossil fuel use, you will find that they're matching pretty much equally in terms of increase. Also, the other greenhouse gases like methane and nitrous oxide is also measured on this facility. And we are using, however, CO2 as that's the most in volume, the biggest greenhouse gas, in parts per million. You can see here like the latest measurements from last month, like this is the average in last month, that we're already at a level of 417, which is up from 14 from last year. So you can see the steady increase there. So our reduction of activities last year due to the pandemic has not slowed down significantly the increase in CO2, atmospheric CO2 in the atmosphere. As this is continuously rising, we are heading towards a point of potentially no return, because these CO2 and other greenhouse gases stay in the atmosphere for a long time and have an unfortunate effect that I will explain in a moment. It is generally understood that at some point, if we're reaching somewhere around 500 ppm, we have an effect of continuous warming that will trigger so-called trigger effects that will emphasize the effect of it. So we will see changes in climate that are not reversible for a very, very long time, because we cannot just suck up big amounts of atmosphere, considering that this is the concentration within the atmosphere around the globe. And removing CO2 to lower this would be quite difficult. So there is a point of no return that we should be aware of. And that's where we, as humankind, would be a good idea to make an emphasis and effort to reduce the intake of greenhouse gases and CO2 into the atmosphere. Do we have a so-called like an organization that worries about this or governs this? Yes, we do. We do have a political organization, and we have like a science-based organization. So the science-based organization was formed first, the Intergovernmental Panel on Climate Change, already back in the 80s. And their job was to provide an objective and scientific view on this issue, and also provide guidance in terms of how to communicate, how to quantify, and also how to deal with the changes that we're going to see in our built environment, in our climate, because of the effects of climate change. And because of the findings of the IPCC, a political body was formed, the UNFCCC, the United Nations Framework for Climate Change, that has a mandate. And that mandate is to stabilize greenhouse gas emission concentrations in the atmospheres at a level that prevent dangerous anthropogenic man-made interference with the climate system. So they have a very clear mandate to say, hey, there is something going on that we are causing as humankind that we should prevent on a political level. And you might be aware with the annual conferences, the so-called COP, Conference of Parties, that are organized to find a way to govern this, find regulations, and find international agreements how to deal with this. For the purpose of our quantification, of course, it's important that we say we have a governing body, which is the IPCC, that provides us with a guidance towards how to deal, how to talk about the problem, how to quantify greenhouse gases. So that's what we draw as a program authority our information from. And yes, there is also, of course, research taking place. But in order to compare notes, in order to do transparent communication on the public realm, it's important that we have a standard to go with so that we can compare notes, we can compare results, and also discuss and find good solutions that are comparable. And so that's quite important to understand that it's not very helpful if you make up your own, because then we're not able to collaborate, and rather use the guidance that's provided by the IPCC. They're providing so-called assessment reports on a regular basis. And in those assessment reports, the issue of climate change and their related aspects are explained. And so they're called assessment reports, or IPCC assessment reports. And they're numbered 1, 2, 5, 6. And at the moment we have the latest one is number 5, but and number 6 is in progress. But we're not using the latest one. For the purpose of creating greenhouse gas inventories on an international level, also for each country, one assessment report is always pointed towards as the one to be used. So again, that we don't confuse ourselves and don't fight over should it be called this way or that way, or don't argue about it. It's the assessment SR4 is the one that we're using for regulated greenhouse gas accounting, and that helps us to have transparent, auditable, and comparable results. Now, what it is about those substances that we call them greenhouse gases is because of a certain effect they have in the atmosphere, and that is one of reflecting heat radiation. If we look towards the sun that provides us with sunlight, you can think about it a little bit like the atmosphere being like a glass, like a window, for example, in the car. The radiation, the light radiation, has a certain wavelengths that happen to fit through the glass. And that's why glass is transparent to us. So if somebody stands on the other side of a glass, this person is hit by light, and this light is reflected, goes through the glass into our eye, and that's why we actually see that person. And in the same way, light radiation comes from the sun, goes through the atmosphere, and hits the ground. When it does, it's going to change its trajectory and also its characteristics, and it becomes heat. It's the same thing as electromagnetic waves, the same thing that happens in a microwave that we're using to connect to a mobile phone, but the wavelength is different. And so if you consider glass as a kind of like a net with a certain size or diameter, so the waves just don't fit through it anymore and it's trapped. So that's why it gets hot in the car if you leave it out in the sun. And similarly, not exactly the same, but similarly, we have an effect in our atmosphere. And cloud, for example, are reflecting back the heat, but also some of the molecules in our atmosphere. Not all, but some. And what it does, it keeps us nice and warm, because without that effect, it will be minus 18 degrees on planet Earth, and there wouldn't be a life as we know it. So having this effect is a good thing to some extent. And it's basically like wearing clothes. When we wear clothes, it doesn't heat. They don't produce any heat, but they keep the heat close to our skin so we don't feel cold. And it's a good thing if it's colder to wear clothes. But of course, it's a bad thing if we wear too much clothes, then we're heating up. And the same thing, it's a bad idea if we have too much substances in our atmosphere that are trapping too much heat. And for a long, long period of time, this balance of trapping heat and having light and of life evolving on planet Earth has been a balance that allowed the kind of life that we're enjoying. So a bad idea if we're messing this up. One of the elements that makes this even more relevant is that clouds, for example, are having a very low lifespan, like 10 to 14 days. It's kind of like if you were like wearing clothes in the morning and then you take it off again in the evening, and then or you change clothes, and then next day you will put on new clothes that are maybe more suitable for the climate on that day. Some of these molecules, like the CO2 and the methane and nitric oxide in our atmosphere, will actually stay there for a much longer time. Some of them like several thousand years. So that again would be as if you wouldn't take off your clothes and you would take on more and more and more. So that's a problem. So the heating effect spins out of control. Why are these molecules trapping heat radiation? It's their molecule makeup. So you look at this small chart here that displays the wavelength of heat radiation, and it shows where in which wavelength these molecules are actually reacting to it, like a resonant, almost like an instrument that is reacting to the wavelengths, and therefore they're reflecting back the heat. And you can see the light blue one, that's a cloud, and that traps certain elements of the heat. And then you can see the CO2 is almost plugging a lot, or it's like reflecting a lot where the cloud isn't. So it has a terrible effect because they're just compounding to each other. So the kind of heat radiation that the cloud lets through, the CO2 will trap. So it actually compounds the effect of our clouds already. And some of the other elements in there have a different characteristics and also a different lifespan in the atmosphere. And in order to express this, we look at all the substances that are considered greenhouse gases, and we know this from the SR4 report, that these are all the substances that have the same effect, that they are reflecting back heat. And they're carbon dioxide, methane, nitrous oxide, then groups of substances, the HFCs, EFCs, PFCs, SF6, and NF3. If you wonder where do these come from, if you burn something, anything, you will create the first three. If a plant would decompose, you would mostly have carbon dioxide being created. Of course, we all know the decomposition of other organic matter will also create methane, especially energy-rich ones. And in some cases, also nitrous oxide is created. These three substances are usually used for industrial processes or as a cooling agent or a foaming agent or a solvent. And there are like lots of numbers of individual substances part of these groups. And then SF6 is used to break a light arc in a transmission station. So because it's so big, SF6, it's able to actually break the electric magnetic flow. And it's almost like a giant switch. And then there is NF3 that's used for screens, but also to make solar cells. So unfortunately, there are two things that come together, that one that we want and one that we don't want. So in their characteristic of reflecting heat, they are described in relation to CO2. And our characteristic of CO2 is our unit one. So in the same way that we have like a kilo or a kilometer as the basis for the metric measurement system, for the purpose of quantifying greenhouse gases, the effect of carbon dioxide over a 100-year period is our unit one. And all the other greenhouse gases are expressed in relation to this. And so the answer here would be 25 means one molecule of CO2 would be equivalent, 1 molecule of methane will be equivalent to 25 molecules of CO2 in terms of their characteristics, what they do in the atmosphere. So methane will create 20 or reflect back 25 times the heat radiation as carbon dioxide does. And you can see nitrous oxide has like almost 300 times effect. And some of these substances have like a terrible effect on the atmosphere if they're released in the thousands. That means that so much more heat radiation is trapped back. This 100-year is a selection that the IPCC has made. So that's a choice. You can change, theoretically in research, you can change this. If you do, these numbers will violently change. And the reason for that is that they are not staying the same time in the atmosphere. So if you would change this to, like, say, only reduces by 80 years, the number for methane will like explode to maybe to like something like 80, because it's not as stable as CO2 in the atmosphere. So this number describes two things: how much heat radiation is reflected and how long it stays in the atmosphere. So there's a relation of two things. You can say, well, that's pretty arbitrary. Why are we using these numbers? Now, yeah, we have to have some way of describing these elements, these physical elements, in a mathematical way. And so that's why it's so important to stick to the correct assessment report, because it changes over time. Our science about what is a greenhouse gas, what is their effect in the atmosphere, has improved. And therefore, if you are like hindering in your climate action because you might argue, oh, I thought methane was 21 and nitrous oxide was 300, then we will waste our times, because it just is a way of of having a metric and of describing this. We know it describes the characteristic. Methane has a stronger effect. If it's 21 or 25, for the purpose of describing the amount, it's not that important. Important is that you can compare your results and find out a good solution and use the one that is prescribed and is used by everybody else in the regulated world. So that's why it's quite important to understand this metrics, and that's what you do in greenhouse gas accounting. Now, I don't expect that you would deal with some of these other substances. I would be surprised. But the first three are probably the most important to keep in mind. Carbon dioxide, methane, and nitric oxide. Because of their strong effect, it's also important not to only talk about carbon, but about greenhouse gases. I'm just going to stop here for a second, check with Erica. Are there any questions or anything that we...
No, there are not yet in the chat, but maybe we can ask to our participants. Do you have any question, anything that you would like to be clarified so far?
Okay, good. If you relate the two things that I just explained, so that these greenhouse gases are trapping heat and they're messing up our climate system. And if you look at the concentration of greenhouse gases, then the obvious understanding would be by how much do we have to reduce the concentration in the atmosphere so that we avoid this catastrophic effect. And for that, we have scenarios that are partly built in something called the Paris Agreement from 2015, but maybe a bit more easier to understand is called a gap report from the UN Environment Agency. And if you look at that report, then you can see in order to reduce the emissions from a scenario where several degrees warming on average would have a catastrophic effect on our living conditions, to reducing this ideally to a 1.5 or even lower element,
430.
The emission reductions have to be at least 60% in the next 10 years. So if you look at your emissions right now, and if you want to align yourself, be temperature aligned or science-based aligned in your activity, it would be a good idea to reduce emissions by at least 60% towards the year 2030. You can have much more ambitious goals towards this. Having less ambitious goals, looking at all the knowledge that we have, is maybe not a good idea. So that's the trajectory that you want to go towards if you are considering all the information that I just shared with you so far.
Sven, we have one question.
Yeah.
Megan asked, what products or activities do those other higher level of GHGs come from?
Okay, so as I said, the HFCs, the HFEs, and the PFCs are cooling agents. So if you are like replacing, for example, your air conditioning units and people are not following good procedures and they're refilling coolant, then some of these substances are emitted. Or if you actually like rip out an air conditioning unit and throw it away, or even an old fridge, then these substances will be released into the atmosphere, which is a very bad idea. SF6 is released if people are irresponsibly acting within a transmission station, and in Europe, in most places, this gas is illegal to be used. And NF3, as I said, is used to etch solar cells, and you can find dirty and clean solar cells. So if somebody manufactures very responsibly with NF3 and tries not to have that emitted too much, then that would be a cleaner solar cell versus somebody that is very careless about using the NF3 and having a terrible effect on the atmosphere, as you can see with the global warming potential from 17,200. Okay, if you look at towards the concentration of all the elements within the atmosphere that we know have a so-called forcing effect. So if you look at towards the climate systems, there's something called forcing effect, which means that like these factors are forcing our climate to derail and force warming. And if you look at all the greenhouse gases together and aerosols and the other aspects, we're already like getting pretty close to 500 to the equivalent of 500 ppm. So the time to act is definitely now, if you consider those things, and not waiting is not really an option, and thinking let's see. One of the things that I already mentioned is the difference between things that happen naturally and things that are done because of human activity. And of course, human activity will involve breathing in and out. But we consider ourselves also a life form on planet Earth, so we don't consider that as anthropogenic. We consider everything that we do and that only happens because of something we do as so-called anthropogenic. And I'm just going to use a very, very, very simplified example here to just make that clear to understand what the difference is. So as we learned, plants are absorbing CO2 out of the atmosphere. And when that emits against in the atmosphere, if the leaves, for example, fall down in autumn, and some of it will break down and go back in the atmosphere, some of it will be broken down by bacteria and fungi and small animals, and will be absorbed and stay in the biome, and maybe also be absorbed into the ground. So not all the CO2 that was taken from the atmosphere will go back to the atmosphere. Only some of it, but the part that does, we consider biogenic, and that's, I'm sorry, this is written in German. So it's biogenic that we are not concerned about. But as soon as we are acting and doing something, breaking, for example, the leaves together, we are maybe interfering with the natural process of this being composted and being gone back into the ground. For example, if we also remove wood out of a forest, it would have a different kind of calculation of CO2. So if a tree falls down, sure, it can also burn down, but it also will fall down, and the decomposition process will absorb some of that CO2, that carbon, into the ecosystem itself, and it will not go to the atmosphere. Some will go to the atmosphere. If we remove it and burn it, then of course some of the CO2, additional CO2, will go to the atmosphere. And so to describe that difference, we call that anthropogenic biogenic. So because of our activities, anthropogenic, originally biogenic CO2 is released into the atmosphere rather than staying within the ecosystem. And of course, if you have processes where things are composted without oxygen, you have methane, and that will be an anthropogenic greenhouse gas, which shows you already that some things that you might think are green are not necessarily good for the climate. And those trajectories of doing things ecologically and climate action were not necessarily always the same thing. And you might want to focus on the climate change first, because that's our pressing problem, solve that, while being, of course, ecologically responsible and considering all the other, do no significant harm in all the other categories. But for example, burning wood, even though it's not, I know I'm not very popular saying this, burning wood is not a good idea because it is at least additional CO2 in the atmosphere, and we already have there enough. And the sun radiation or the heat radiation, they don't care where the CO2 comes from. So if we can avoid it, we shouldn't burn anything, like no coal, no fuel, no gas, nothing. There's one exception, that's methane. If you burn that, you understand that you remove 24 parts of it. So if you change methane to CO2, then you are also reducing the concentration of a greenhouse gas in the atmosphere. So don't burn anything other than methane. Naturally occurring methane would be a good idea to understand the difference between anthropogenic and biogenic. In our approach, of course, we're focusing on reducing the anthropogenic introduction of greenhouse gases into the atmosphere. Now, where do these things come from, all these greenhouse gases? On a global scale, if you look at all the inventories of all the countries, then you will find that almost 75% is related to energy generation. And that's a generic consideration. So this includes mobility, because basically you are creating the trajectory and you need energy for that. And that's also like the use of energy. If you are heating a building, you are related to energy. So you need heat, you need light, it's also energy. And of course, if you are building something, making something, you also use energy. If you are making cement, clinker, you are burning energy. So everything is related and comes back to clean energy. So the vast majority of what you do, or what we do as humans, and their greenhouse gas emissions are related to energy. Because if you are, for example, changing mobility to using electricity, is of course important that the electricity that you use is of low intensity. If you are building something, you want to have, if you're even making marmalade or jam and you're cooking, in order to make that product low intensity, it depends on what energy you're using. If you're using fossil fuel, if you're using electricity, and if you're using electricity, where does it come from? Does it come from a solar cell, from a wind turbine, or from a power plant? So 75% of all the greenhouse gases, either directly or indirectly, are related to energy. 18%, about 18%, is related to agriculture and forestry. While forestry is a large part of that emitter, and that's deforestation. So that we are continuously cutting down ditches and old growth forest. It has a terrible effect on the greenhouse gas emissions into the atmosphere. And of course, also agriculture, the use of synthetic fertilizer, and the related emissions. So making of the fertilizer, it's energy related, of course, but there are natural oxide emissions related to using synthetic fertilizer. And if you wonder how much the animals are related to this, so of this 18%, 6% of that is related to our domestic animals that we use for food production. And then 5% is industrial production. That's where some of these chemicals are related to. So it's not energy use. It's if I'm actually using a solvent or a cooling agent and I'm releasing it. And 3% is related to waste and water. So those are the big areas where those greenhouse gases come from. So resulting, if I want to make a big effect, I definitely should think about energy generation and where energy comes from, or where I can use or have a process that doesn't use any energy at all. Energy savings is okay, but actually you want to have something that actually doesn't use energy at all. And an example could be, for example, if you retain your rainwater and you use that rainwater on site, you actually save energy for the water that is not treated when it goes into the sewer system, and for water that is not pumped towards you. That also uses energy. So that's also indirectly uses energy, and that's a way how you completely avoid something having to use energy. And of course, forestry, and it's of course like an important topic in this here in British Columbia. And if you are considering not burning wood, but actually using it, you only want to use wood to store the carbon. So if you make furniture out of it or local products that you can use in your local processes, then the carbon is not released, at least not for the most part. But ideally, of course, you want to have a living forest, stay living, and don't kill it. And changing in agriculture, of course, as well. If you look at the personal footprint, so where do the average person in an industrialized country, I have to say that that's of course not relevant to somebody who doesn't live in an industrialized country. An industrialized country, where would be more or less all the emissions come from? This is now a different scope, I have to emphasize. So, or a different categories are considered. On the left side, you have all the ones that are actually created within a jurisdiction. And on the right side, you have a person that is also consuming products that are not made in their jurisdiction. So the big red part here, the products and services, will include things you buy that may be made like somewhere else, made in Ontario or in America or in China or in Vietnam or Indonesia or somewhere in Europe. And so the emissions actually will be created there, but it's still part of the emissions that are related to your behavior. And it's also called services. So the fact that that if you have like a recreational facility, a swimming pool or ice ring, and you're using that for a couple of hours, it will contribute to the services that you use. And of course, also up to the federal government that's handling your taxes, whatever. So there's all kinds of services that you use as part of living in an industrialized country. And those are a majority of your emissions that are related to your personal footprint. The next big one is mobility, of course, and that's all kinds of mobility. So that's like if you're traveling, if you're going to work, if you're going on holidays. So whatever mobility is about 20%. And 15% is the electricity use, so indirect energy, or if you are having a district heating system or a district cooling system, that makes 15%. And sorry, that would be the 7% is the electricity, and 15% is your direct energy that you use where you are right now. that powers a boiler maybe that heats your room, or of course in BC that's not that applicable because a lot of cases we also have heating, baseboard heating using electricity. So in some cases we might have instances for a person in British Columbia that the direct energy use would be much lower than 15%, but that's unique to our climate zone and our energy mix here. That would be probably much smaller for a BC residence. But overall, if you look at all the industrialized countries, that's a characteristic that you can find. We will come to the point how much I can change that and how much influence I have this. But it's important to understand that energy, again, here, direct energy, indirect, or mobility is again energy, and also how these things are made. Basically, it's all about energy. That's where our greenhouse gases are produced mostly. So if I look at that red area that I marked for the personal and say, okay, how much can I not buy myself out of the climate crisis? And the answer is, let's think about this. So if you are buying a product, even if you're buying like a locally made apple juice, how much influence do you have on how that's transported? The actual vehicle or truck or horse, whatever is used to bring it from a farm to the shop or the cooperative place where you buy this. You have very little influence and very little knowledge unless you know the person, how that's transported. If you look to what's back in the supply chain, and you wouldn't know where the bottles are made. Maybe the manufacturer is very, very, very diligent about these, but usually if you're standing in front of a shelf full of products I can buy, none of this information will be available to you, or what kind of energy was used to cook the water, which the bottles were cleaned before the apple juice was put in, or the apples were cleaned, and how was the water pumped, what kind of energy was used to bring the people to the place where the apple is growing, what fertilizer has been used, what other machinery has been used to care for those trees. So that's looking back in the supply chain, but also if you go, what happens if I don't eat all of the apple or don't drink everything of the apple juice? What happens afterwards? Is there a bio and organic waste diversion program, or is there a bottle recycling program, and what happens with my waste in general? So direct as an individual through your purchasing decision, there's very little you can do. However, you can work in your community together and maybe address some of those aspects, like how are things transported in my community? What is done with organic waste? How are recycling working? Are we just collecting some things and then sending them far away to another country? Yep, somebody raised their hands for a question.
Yep.
Go ahead, Eduardo.
Yes, my question is, you say we have influence or no influence over what we consume, but as Helen was saying, there's more influence in how we use energy than how the products get to the store. So why are we putting attention to something that we have no control over instead of the ones that we have control over? That's my question.
Yeah, because you as an individual don't have influence over it, but you can have influence as if you work together in a community. As a community, you can decide if you are having, for example, a community solar park, like in Nelson. You can produce energy together, and maybe if there are local producers, they can then use that low intensity energy. You can come together and ask for a organic diversion program, or decide that the waste of the community should be treated differently. That's the kind of community projects where you can make a difference if you work together and address some of those elements that you as an individual wouldn't be able to influence.
Well, the question is, why are you bringing the orange juice instead of the community solar park? That's my question. Why are we bringing something that we have no control over instead of bringing attention into something that we could?
I go from the small to the big, from the individual to the community.
Okay, because I think what Helen brought up about if the wood that is being used for energy has been quantified, that's something that we will be really interested, because 25% of the homes in the Commons Valley use wood, and not the orange juice that goes to the store that is such a little impact on the big picture in our community.
Yep, I agree with you, but that's why we're moving away from that. I'm just starting at that point to move away from that and show how you can change that. Let me flow with this.
Okay, go ahead. Yes.
I mean, I agree with you that the small thing doesn't make a change. So that's what we want to get to, that that you want to look at the bigger picture, and you want to look at the things that are happening in the community. And that's what the challenge is about, that you are looking towards those things and trying to find a difference. If you are looking into your personal footprint looking towards what most likely the community footprint is, unfortunately, we only have data at the moment from 2012, and it's not complete, but just to order of magnitude. So 400,000 tons is the community inventory at least. Most likely it's much bigger. And the average Canadian footprint is around 17 to 20 tons of CO2 equivalent emissions. So the order of magnitude, we want to, of course, address the bigger picture, as you also pointed out. If you want to understand what a ton of CO2 equivalent is, to just imagine it like in the picture, you can imagine yourself like a hot air balloon, and the space.
Don't worry about it. I know how it's done. I'm an engineer, so I'm pretty aware.
Yeah, but you're not the only one listening. So do you mind muting yourself?
No, yeah.
So if you imagine yourself a hot air balloon, and the space within the hot air balloon, and you would draw a circle, that's probably like more or less a ton of CO2. So that would be all CO2. That's how much a ton of CO2 will look like in the sky. And if you think like about 17 to 20 hot air balloons that you are, as a person, blasting into the atmosphere, then it gets pretty busy above you. So that's basically the trail that you're leaving behind through your personal life. But of course, if you look at the community and you will take the same picture, there is a lot of hot air balloons that the community as a whole will blast into the atmosphere. Okay, so again, the message that we want to send today is a very important one. So you by yourself, don't be burdened with solving the climate crisis. Connect yourself. Look at your community around you, and ideally work with other people together. Understand that not everybody sees the world exactly the same way as you are. Every community is very diverse. People have diverse means and needs, and also have different priorities and focuses. And so it'd be good to have an approach where you come together. Only we as a global community can solve this problem. And that involves accepting diversity. There's more than one view, and collaborating, talking to each other, engaging with each other, understanding each other's needs, and also abilities. Not everybody has the ability to, I don't know, buy an electric car tomorrow, would be things that are important to consider when we are looking at the community. And then as much as you can, we would encourage you to work together and to make a difference within your community for the community. Some examples of things that are directly lowering emissions and things that are enabling emission reductions. That's an important difference. And again, looking at the community, some people might not be, maybe want to put a solar panel on their roofs, on their house, but they don't know how to do this, and they don't have the money to hire an engineer or a consultant to do this. And maybe there are ways of enabling this for the community. One best practice example that's usually used in Canada is the so-called Arctic Energy Alliance. This is the office here on the left side in Yellowknife. It's an office where you can go to, and any questions you have. So how do I put solar panels on my roof? How do I don't know, retain rainwater? Or how do I use geothermal energy? You can just go in there, and there will be somebody that explains you what it costs, how it's done, so you don't have to spend any money as an individual. And it's a facility that's there for every single member of the community to answer these questions and enable them to make a difference in their community, or for their school, or for their kindergarten, or whatever it is that's there. So that would be an enabling activity. It's not putting solar panels on somebody's roof, but it's enabling a community to have access to this. Another project that a long time ago the city of Osnabrück has started is to have like infrared pictures of the whole community and see where the most energy is like wasted. So you see that map here, this infrared map, where you can see some of the houses are insulated very well and some are like insulated terribly. Maybe you have a means to make this publicly available on a community level and find solutions, strategic solutions to both reduce the energy use, but also to switch to renewable energy. Here on the right side, you see the City of Surrey Biofuel facility that we also have ourselves of our work. We have helped to set up. And that's a groundbreaking facility that produces biogas for the purpose of putting it into the gas network and also used for transportation out of green waste, yard waste, and industrial waste. And that's a good thing, because you need a certain size, a certain feedstock size, in order to justify the production of grid-grade biogas that you can actually feed into the system, because you need technology that cleans up and refines a little bit the biogas so that it can be actually fed into the grid. And so that's a facility that basically showcases how that is done. And it's a public private partnership, and it also has received lots of financing. There is lots of financing available on the federal, on the municipal, on the provincial level. So enabling projects like this would be also an option, that we say, hey, we want to have a different solution to energy. Instead of firing with wood, we want to have an district energy system that's powered by biogas, for example, or geothermal energy. Then that would be a way to come together to enable the buy-in from a community. But that's the enabling part, that people, yes, say that, decide that's the one we want. That will be the enabling activity, and you don't have to build a facility, but the enabling part would be that the community agrees that that's the solution that they would want for their energy solution. Or of course, that there's more direct ways. There's a community wind parks that are very popular in Europe, that a community comes together and decide, we want to have a wind park in our community. Everybody owns a share in this. Once it's built, everybody earns money from the electricity. So it's a money-making business, because wind power is very efficient in terms of energy generation. Once you have enabled the finance, that's of course the hurdle at the beginning. But after that, it's basically a revenue source for everybody involved. And then the community solar panels, where the idea is that you help finance basically your own panel in order to create the energy for yourself. And the city of Nelson is usually widely considered as a example of best practice within that in BC. On the left side, you have a project in Denmark where there's a community project that uses seagrass that's already dead, and it's washed ashore, and it's cleaned there and dried, and it's used as a building material because it's a perfect insulation. It's like fire retardant. It doesn't burn because of the salt content, and it's a perfect insulation material to use in buildings. So it's another more creative example of how you can create jobs, building materials, and use knowledge about the built-up environment and the natural environment to create lower emission solutions, and also create jobs and building materials within your own community. Another best practice example that I want to highlight that's not too far away, just across the water from you, so to speak. It's in Cafet Regional District, and it's the Resource Recovery Center. It's a very popular concept also in Quebec. There are quite a number of them already set up. And this is a concept that's just coming towards BC, where the idea is that you are finding solutions to utilizing and upcycling the materials that you have within your community, so you don't produce any waste. So building material is used, plastic is used, and there are creative solutions to use those materials in a community center, where you don't go to play bridge or ice hockey or whatever, but you actually find creative solutions together to build materials and substances within that are used in your community. And another one for mobility, it's an island community in northern Germany that is introducing a self-driven electric small minibus that's demand-oriented, so to demand-based mobility. It's probably, in our understanding, the best-in-class solution for a special rule in smaller communities, because like the big traditional fixed route bus system doesn't work, but a demand-driven electric bus is probably a very good solution for community. And if you want to be very innovative to have the solution for everybody available, then maybe that's something that you want to look at, learn more about, and develop again the community buy-in to say that's the kind of transportation system that we want, because that's the future. Another opportunity is how to treat wastewater. Of course, the traditional way is to have these big ponds there made of concrete to treat wastewater, which is basically a greenhouse gas production facility. Even though they're aerated, it's because of the high nutrient content, it still emits tons and tons of methane. And it's municipal waste, usually out of households. It's not that toxic. And you can feed that to poplar trees with a drop feed and have it completely absorbed. There's no contamination to the soil. There's three projects in BC, central BC, where that has been successfully implemented, where wastewater is turned into fiber instead of emissions. And then you can use those fast-growing trees to, ideally you don't burn them, but you produce maybe building materials out of them, or household or single-use, instead of single-use plastic, you have single-use fast-growing forest, coffee sticks or whatever, or spoons, or even cups. There's lots of things you can do out of poplar wood because it's soft and easy to work with. And one last example of what you can do in a community. This might be a school where you can build a shelter belt around on the weather-facing side with coniferous trees, reduce the amount of energy in the same way as the airflow makes us cold, and the clothes shaves us. You can put a shelter belt of trees on the weather-facing side, reduce the energy demand, and put like deciduous trees on the sun-facing side, and lower the amount of cooling energy that's necessary in summer. In the winter, of course, when you want to have the light comes through. So very low cost, clever solutions where you can use natural assets to lower emissions within a building. Of course, you can also change the energy source in this building to geothermal and air heat pumps, but that costs more money and takes longer. But with stuff like this, you can make a big difference in your community with very low finances and just a clever approach. Okay, I'm going to now to the governance part. That was the last section, but I was going to stop here. There were a couple of questions. Weren't there, Erica?
Yeah, there are a couple of questions. So there is Ellen that asks, could this information be collected at the same time that municipal taxes are paid? Of course, this would only cover homeowner, however, may provide a good estimate. Maybe Helen, can you specify to which part are you referring this question?
Hi, sorry, I'll answer that. I think I would need to look into that. It's a bit more complicated, Helen, but I'll look into that and I can get back to you. Not from my understanding, but I'll check that and let you know.
Okay. Okay. So, what else? Questions there?
Yeah, and then Eduardo say that
I'd just like an opportunity to clarify. That was a second question to my initial one about if at the moment in the Comox Valley, if greenhouse gas emissions from wood burning were being collected. And so there was a reply, and the second comment is the one that Erica just spoke to. I gather we don't have an estimate of how many wood stoves we have, and I was just making a suggestion. Could that information be collected at the time where people pay their municipal taxes by just, do you own a wood stove? So I just wanted to give the fulsome discussion regarding that. Thank you.
But I mean, that could be also a community project as part of this challenge, that you say, well, in order to lower emissions, the most important thing is to have a community inventory, which includes the wood stoves. For example, that might be something that you want to submit to this challenge and say, here is a way how this could be collected. And ideally, you would do a survey of some of your neighbors or community members to say, yes, I'm okay with doing it that way. And so that your activity would be to get the buy-in, the community buy-in for this.
So just lastly, I just want clarification. I was under the impression that this kind of a scorecard was being developed by the regional district at the moment. Is that correct? I know that Courtney has done a great deal of collating their data, but I thought it was going to be a broader, more regional initiative.
Helen, it's Lana. I'll take that one, Daphne, just because I'm working on that project with Robin. So Helen, we are developing a dashboard. I think we've talked about that with you with the RGS indicators, and so that work is underway. And we've made a fair bit of progress in the last several months, and we're looking to do a soft launch, being an internal launch in June.
Wonderful. Glad to hear that. Thank you.
Great, thanks.
Erica, you have some more?
Then there is Megan that is saying goodbye and thank you. Thank you, Megan, if you are still here. And then there is Eduardo that comments that maybe wind is not the best source in Comox because there is not enough wind. But yeah, these were kind of a different example to show which variety of thoughts we can put in this challenge, in this project development. And then Eduardo is commenting again. It is about 30,000 tons per year from wood stove in the Comox Valley, about 6 tons per wood stove from 25% of households that use wood for heat. Yeah, like for example, this is a good example, I think, to collaborate, like someone is asking some information and then maybe within the community there is already someone that has some information. So as Daphne was suggesting, we encourage you to share your question in the forum that I put again in the chat in a bit. So like whatever question you have beyond this workshop, please write them in the forum, and the forum is open to all the community members, and so everybody can answer, and so it's a really great place to share ideas.
Thank you for that. That's a very helpful advice there. Okay, if you ask yourself, so how is it governed in Canada, greenhouse gases, from a top view? Then, of course, we have already since 2004 some governance on this, and there is greenhouse gas reporting regulations for big emitters, which are 10,000 tons of CO2 equivalent. Stationary emissions, and you can actually see all the emitters. They're like here scattered around on this map, and you can see their emissions, and this is transparent information. So we are living in a country where this is governed, and there are not many where that's the case, and in exactly this way. Actually, there's hardly any that in the world, and also certainly not in Europe, where that's governed that diligently as it is in Canada. And here in BC, of course, we have also a reporting regulation for industrial emitters. We have the regulations for the government itself, which is called Carbon Neutral Government Regulation. So they have a commitment on themselves, a regulated commitment that they have to be carbon neutral. That means that they have to actually measure the greenhouse gases from all their facilities, and as it so be, we actually provide the system for the government to do so, to enable them to track the greenhouse gases from 30,000 buildings and facilities. And that's clearly defined what the scope is, and also how to go about it. And then there's a climate action charter, which is a self-imposed commitment for municipalities, for local governments, which the Comox Valley is part of, and also the Green Communities Bill, which is regulating that municipalities or local governments in their planning need to consider the reduction of greenhouse gases. They have to do an inventory every year, and through the so-called CARB, the carbon tax refund system, they're reporting every year on their corporate inventory, and they're also, of course, encouraged to do a community inventory. What's relevant to our activities or discussions today is that all of them, all these requirements, use one single quantification methodology, which is the DC best practice methodology for quantifying greenhouse gases emissions. And they're also a resource on the forum. If you go to the Connect, there's a link towards this. And that's basically our guiding authority on how to quantify greenhouse gases in BC. So emission factors and how to go about quantifying the greenhouse gases in different areas, how much greenhouse gases are related to using electricity in BC, and all that questions are answered in that one document. That's basically the reference that we use, and why we're using it, because it's the one that's regulated in BC, and we should be glad that it is regulated in BC. Again, it's absolutely unique in the world of having this framework in place and having this transparency, and also allow us to track greenhouse gases within the provincial and the local environment, to do so. So I strongly encourage you to use this, and I don't know, be also proud. This is made in BC. It's an absolute fantastic solution that has been developed in 2007 and going forward, and all the local governments are working hard to work with this and utilize this for you and for everybody's benefit. There's also something called, there's an international standard organization that provides a greenhouse gas accounting standard, which I will mention in a moment, but they also have some ideas about how to make credible claims. And in a way, of course, that's what we want to empower you to do, that you can make a credible claim about the emission reductions that your suggestion, your submission will make. And what are maybe criteria that are important to consider there is to use the most applicable standards and methodologies, which I just pointed you at, which is this BC best practice methodology, and a standard called ISO 14064-2, which I will mention in a moment again, that you can use for emission reduction projects. Collect meaningful data, that's obviously, and it should be transparent of where the data comes from. When you do have to do some methodologies, for example, how much emissions are related to planting a tree, or how much emissions are related to avoiding a ton of organic waste not being put to the landfill site, or how much emissions are reduced by taking a gasoline car off the road. All of those aspects require additional methodology that you will not find in any of those documents, and I will provide some more resources of where you can find methodologies. Ideally, you want to use BC methodologies that are accepted and that they use in your guidance. You also want to, of course, document how you collected data and where from, and make it as transparent as possible. Not just say, oh, I just assumed this. Even if you make an assumption, just make it clear that you say like, well, it was too difficult to find out what it is. I read a book about it and I took the number from there. That's fine, as long as you make that clear, that where it comes from. Also be clear about what you include and exclude. So there is an importance that you say like, this is what happens today, and this is what we suggest happens tomorrow, and make sure that these things are like clearly the same, functionally the same thing. So today I'm going to buy some groceries, and tomorrow I'm buying some groceries. I'm just do it differently. It's not like I'm buying some groceries yesterday and tomorrow I go fishing. Those need to be the same things, so you can compare them and be very clear of what you're looking at. Just the transportation or the energy generation for the community. And you also want to be very clear about what aspects of that process you're looking at, the production of energy, where it comes from, or the transportation of water, whatever it is. Be very clear about the aspects of supply chain that you're including. And also be clear about if you're looking at the life cycle of something, how something is made, or if you're looking at the operational part, so when it is in use. So those are like some tips that you will find if you look at the standards. You don't have to look up the standards, it's just the tips of the slides. And this, as it is recorded, will be available on the website, so you can go back to this part of the presentation and look up. What were things that will help me to make a credible claim? Credible claim as part of your submission, but also to the public when this project is interactive, that people in the community see, this is a credible activity to lower emissions in our community. In general, in greenhouse gas accounting, what we do in our work is boundary settings. So we're like very clear what we're looking at. So-called SSR selections. I will explain in a moment what that is. Collect activity data. That is like, I don't know how much gas has been used, or how much wood has been used, or how many people are traveling. Any transformation that you have to do, like transforming, I don't know, people going to work, or using home delivery or whatever. And you also want to be clear about the emission factors, which you will find in the methodology, and then do the quantification, which I will also explain in a moment. SSR stands for sources, sinks, and reservoirs. So a source is something that emits greenhouse gases into the atmosphere. A sink is something that absorbs, mostly CO2, from the atmosphere. And a reservoir is something where there is no emissions. So a piece of wood could be all those things. So it'd be a sink when it grows as a tree. It'd be a reservoir or a pool when you make a piece of furniture out of it, even if it's that part of the wood. And if you throw it out and it rots outside, it will become a source. And even if you burn it, it will be a source of emissions. And so this is how a piece of wood through that lifetime could be a source, sinks, and reservoir. And so what you want to do is you want to clearly identify what in this process is a source, what is a sink, and what's a reservoir when you do the quantification. Most likely in your activities, you would consider CO2, methane, and nitrous oxide. Not in all cases, but as soon as something is related to energy and burning, you most likely would. And I just want to explain how you apply the global warming potential here. And that is that you take the global warming potential, and if it is 1 ton of methane that's emitted, so it's pure methane, take it by 25, and that gives you the amount of CO2 equivalent, the greenhouse gases. And if you have nitrous oxide, you take it times 298, and that gives you the emissions in greenhouse gases. And then you would add all those things together, and that's when you get the total greenhouse gases associated with an activity. So if you burn a liter of diesel, it will have a certain amount of CO2, have a certain amount of methane, and a certain amount of nitrous oxide. Those certain amounts you will take times the global warming potential, and then you have the greenhouse gases. Sometimes you already have the emission factor expressed as greenhouse gases. You have to be very careful if that has an E or not. Then those things are already built into that calculation. So if you say like 1 liter of diesel emits about 2.58 kilograms of CO2 equivalent, then all the other greenhouse gases associated are already built into this. So you have to be careful if you are dealing with methane or nitrous oxide or CO2, or with the emission factor where that's already built in and expressed as greenhouse gases. But that's also explained in that methodology that we are pointing you to. If you are looking at the quantification, there's different ways of how you can look at something. So you can make a corporate footprint of an organization. You can look at a product, or you can look at an activity, the reductions. So the standard for that would be 14,064-1. That would be an organization. So the regional district, the corporate inventory will be done based on this, or a company will do this way. A product, so your mug or whatever, or a piece of fuel could be done with doing this. It will be product footprint, and then everything from cradle to grave will be included. And that would be something that you can look at if you are saying, well, we want to make something locally. And then, of course, the transportation plays a role, but also how emission intensive it was made, where it was done, where it was produced. And of course, if that's a jurisdiction they use coal plant, then automatically the footprint of that product will be much lower if it's made in a jurisdiction where electricity comes from hydro, for example. And the standard, the ISO 14064-2, it's not something you need to train and learn about, but that would be the closest to orienting where you want to orient yourself in terms of how do I express an activity that will lower emissions. And basically that stipulates that you have to describe the situation without the activity, and that you have to describe the situation with the activity, and then compare, okay, what are the improvements through changing the activity? It's probably the most important thing that you need to remember from this. But if you are going to go like overboard, so to speak, or go very, very detailed, then this ISO standard 14064-2 will be the relevant one, and that will provide you the guidance how to do this in great detail. So what are the criteria that are important from that standard to remember? So first of all, there's so the situation before and without the project, and without the project is called baseline, and the other one is the project line. Those are the two scenarios that you want to look at. That you can change. So today I'm heating with wood, and tomorrow I'm going to use geothermal. Those will be the two scenarios that you compare, and this will reduce X amount of greenhouse gases. The quality criteria of those is that it, of course, should be additional. So it shouldn't be something that you have to do anyways by law or have to do next year. It should be an additional activity. It should be real. It should be functional equivalent. It should be the same thing. I'm still heating a house. It should be ideally owned by the within the community, so not be a reduction outside of the community. It should be not reversible, that someone goes, oh, today I'm not for 3 weeks I'm not driving the car. That's not really permanent, because then after 3 weeks they're driving the car again. So it's not a real difference that will last. And endurance will be an important part. And it should not also be a part of leakage. Leakage is a concept that you are just saying, oh, we're not going to produce electricity anymore here or heat. We're just going to produce it somewhere else outside of Comox. And so there's zero emissions related to this. That's not quite correct, because there are still emissions. You just have exported them, and that's called leakage. And you only should count things once. You don't have to go validation and verification. That would be if you in a more industrial, more professional setting. That's not so necessary. But some of the other aspects are probably things that you want to consider. In terms of resources, there is something called Becoming Carbon Neutral, a guidebook for local governments of British Columbia, on a website called Toolkit. And that's something that's provided for local governments to initiate community projects that are lowering emissions. Make use of them. There are several scenarios: fuel switching, solar thermal, household organic waste, low emission vehicles, and avoided deforestation. So these are all scenarios within this guidebook that have a detailed toolkit for the quantification. Some of them have even Excel sheets where you only need to plug in the numbers, and it gives you then the emission reductions. So if you are active in one of those areas, we will strongly encourage use the quantification within this guidebook. It's a piece of cake to use. It's very, very easy. It's designed to be easy. And it will be in a completely 100% recognized emission reduction quantification in BC for your projects. It doesn't mean that you have to limit yourself to those projects, but if your projects have anything to do with any of those topics, we strongly encourage you to use those quantification methodologies. It will make your life much easier, and also has some good tips in terms of how to organize and document the project activity. So this is like our top tip for today, is make use of this guidebook. It's there to be used. It's exactly designed to support local emission reduction projects. And then if we go back to the categories that are stipulated for the challenge, so in the renewable energy area, make sure you apply those principles that we have talked about understanding, okay, how is the energy produced today and how would it be produced tomorrow, and what would be the functional difference? Are you producing exactly how much energy, and what's the difference in terms of greenhouse gas intensity? Transportation, there are many forms of how these projects could take on, but consider also, also by the renewable energy, of course, consider like enabling activities. And for the transportation, it doesn't mean that you have to buy an electric bus as a community, but building the buy-in to say what is the low greenhouse gas transportation solution long term, not just maybe one bike lane or one electric car, but how do we organize transportation within our community, and developing a buy-in or even a plan for that would be a huge help, and will also complement. So the idea of these community-driven projects is that you yourself, in your daily life, it will impact you directly, that you come up with solutions that you say, wow, that would be an ideal scenario for me, how I want to have transportation being done in my community, that you provide that vision and that impetus and that buy-in to say, that's the kind of solution we want for our community. On the waste side, of course, there is like avoiding waste, there is like dealing with the waste, and maybe upcycling some of the products and making something useful, energy, recycling. There's lots of interesting things that you can do on that side. Always think about not only about the classical one, I don't know, bottles and plastic, whatever. There's lots of more materials. Building materials, for example, is also a huge source of waste. And some cities have already developed de-assembling concepts. So where a building is not just smashed, but actually de-assembled. so you have the maximum capability of utilizing the materials. And there are quite some sophisticated projects on the resource recovery side, where even some people take out windows and make sure they're still intact. So like having like a secondhand window or a secondhand door. There's quite a lot of materials in buildings that we waste today by just smashing everything to pieces, that through a de-assembly process could save tons and tons of energy and associated greenhouse gases if they would be reused, and it will also make building a house much cheaper if you are reutilizing materials. So that will be a project that will have a huge impact on built-in carbon in the community. And of course, water management, as I mentioned, the retention of water, the reduction of use of water, and also, of course, how water is transported, and freshwater reservoirs, how they're protected. All of those things play a role. But of course, also wastewater, how wastewater is treated, and what you do with this if you can turn that set of emissions into fiber. On the sequestration side, I'm sure, protecting forest lands and restoring wetlands is something that I'm sure you're aware of. But don't forget the oceans. The oceans in front of your coastlines are a very important carbon storage. So the carbon that we produce and the greenhouse gases that we produce, but mostly the CO2 that we produce, is absorbed in the oceans. And the plants in the ocean, seagrass, for example, is actually sequestration it out of the water. And that is an important factor. So it's an indirect sequestration, a very effective one. And it is a recognized way of sequestration. So maybe that's something that you also haven't considered so far, is seagrass patches in the coastline in front in your coastal area. And then, of course, food, local food productions, for example, in the ocean, like a sustainable way of producing maybe algae or other forms of food that microgreens that can be produced in a very small space with very low resources and very low energy implications. That would be some things on the production side and supply side, but also, of course, what you do with food that's not sold or cannot be sold anymore, or even food waste. How is that dealt with, and how is that diverted, and what interesting and fun solutions that you can find to work with that. So just a lot of inspirations using this knowledge, but hopefully gives you more options to participate and even also spread the word. If you have heard about a good idea here or thought about one yourself, talk to your peers, to your neighbors, to your colleagues, to your people that you work and live with. Say, hey, wait a minute, there's something that we could change here, and engage them and participate in this great opportunity to make a difference in your community. Okay, just a small break to stop the recording part.
Yep.